Hey everybody, I just wanted to take a little bit of time and give you your pre-lab lecture about the Greenyard reaction. One of the things throughout this whole little video is that I'm going to be describing Greenyard reactions and probably telling you to keep them in, keep them dry, keep them water-free. Greenyard reagents, Greenyard organometallics in general, will react faster with water than they will with alcohols or aldehydes or ketones or esters or whatever it is that we're reacting them with. And so we just want to make sure that we keep our reaction mixture dry. And as such, that's going to be the considerations that as we go forward, we're going to try to make sure that we use the dry factor or the dryness factor to kind of guide some of our decisions that we make. So let me put this down here and we'll do this here. Okay, so what am I doing? Okay, so let's first take a look at this guy. Okay, so here we have it. You can see it says dry ether. Okay, the ether that we use is going to be new the night of lab. So we're going to break out a whole brand new can of ether and start using that. Even opened ether has the potential to have a little bit of water in it, which can lower your yield. Okay, and so it's actually not until we get to this product here that it is water safe. Okay, and so here we've created the Greenyard reactant or the Greenyard reagent for this next step, and even if so, water shouldn't be in here because the Greenyard reagent won't form. But then in the second step of the reaction, we shouldn't have water because it's going to react faster with the magnesium bromide than it will with the ethyl acetate. So it's important to keep that in mind when we're doing that. So on the first night of lab, we're going to get to the point where we want to get to here at the very least, because if we let this sit for too long, if we let the magnesium bromide sit, it's not going to stay. So we have to at the very, very, very minimum get to this part. Okay, it would be awesome if we got to this part by adding water and getting rid of the magnesium bromide, just because it's more stable. You let the magnesium bromide sit in your reaction mixture, it's going to be it could be, I don't know, it can just be difficult, I guess is what I'll say. Now, I'll change colors, and I want to talk to you about something else here when we're looking at the reactions. I want to point out this 2 here. That 2 means that we need 2 Greenyard reagents because that's going to react twice at the carbonyl carbon. Okay, and so I think it's important for us to note that when we're doing our physical constants, when we're doing those calculations, that because we need 2 here, in essence, we're making 2 and 2 and 2, and we only have 1 of these. So the ratio that we're going to need to deal with, let me move my camera a little bit. Okay. The ratio that we're going to need is a 1 to 2 to 2 ratio for ethyl acetate to magnesium to butyl bromide. If you don't have that, the reaction is going to be not very good. See, this is my yucky frowny face. Okay, so that's the warnings that I have about the stoichiometry and about water. Now, keep in mind that we are using concentrated sulfuric acid. Concentrated sulfuric acid is, to say the least, not very pleasant if it gets on your body, so just make sure that you're using that correctly and safely. And now let's take a look at some of the things that are going on here, okay, in the directions section. Okay, well, the first thing you'll notice is that we're actually going to use the fume hood. Okay, now when we do that, you're going to have to clean everything. Everything should be dry. Okay, to get it dry, we're going to clean it with acetone. before we even acetone, before we even begin. What the acetone does is it gets rid of any of the water that's floating around in the glassware. Okay, and when I say this, I mean the round bottom flask. We're going to get rid of any of the we're going to clean that out really well. Okay. And then also we're going to heat the solid magnesium up to get rid of any water that happens to be adhering to the surface of the magnesium turnings or the magnesium ribbon, depending on what we're doing in the class. So we're going to do this by heating that magnesium with a Bunsen burner. Okay, it's actually, I think in this lab we have a Fisher burner. We may have both, but I think I use a Fisher burner. This is slightly different. Regardless, we're going to heat it up, and I'll show you how that works. It's going to be kind of neat. Maybe I'll ask somebody to record it, or you can record it so you know what it looks like. It's kind of neat what happens. And then you want to make sure that, and this is an issue that we have here, so you've heated up the magnesium in the round bottom flask, the 300 ml round bottom flask. Okay, it's a 3-neck round bottom flask, so you're going to have a reflux condenser here, and then you're going to have a dropping funnel here. Okay, and then this is going to be sealed, okay, with a stopper. Okay, now I would use a glass stopper. Okay, but that's just me. Okay, even though it says we're not going to use a stir. Okay, we're going to use a magnetic stir plate. Okay, and so anyways, I get to this. You're going to heat the magnesium without any of this junk on it. Okay, just in the flask. But then you have to wait for the flask to get cooled, because we're going to add 85 milliliters of ether. If you don't wait for it to cool, ether's boiling point is 35 degrees Celsius. It's very, very low. So if you're not waiting for the magnesium to cool, then what's going to happen is the ether is just going to boil, and you're not going to have the 85 milliliters that's necessary to do that. Okay, and then you're going to and so then you're going to add that, and then you're going to dissolve the N-butyl bromide in another 40 milliliters of ether and put that into the dropping funnel. Okay, everything's going to go into the reaction flask once the magnesium is in there, and once everything is set up, it's all going to go through the dropping funnel. Okay, and so that's really what you're trying. That's the way that we are limiting the amount of water, the exposure to the atmosphere that there is. Okay, another thing that we're going to do is on top, and I don't see that here. Okay, now another thing that we're going to do is on top of the reflux condenser, we're going to put a drying tube. Okay, now we're either going to make one, or we're going to use ones that are provided to us. And the point there is you can't seal the reflux condenser, because now you have a sealed system, and basically you're making a bomb if you do that. But if you add a tube that is still open, and then put a desiccant in here, or something that absorbs water, it's still open to the atmosphere, but whatever comes through, or whatever atmosphere is there, is going through this tube that is dry, that's going to dry the air. So it's kind of neat. Okay, now here's the real finesse of this lab. Okay, I've been known to say that a lot of organic chemistry is the actual reaction stuff is real easy. I say you can train a monkey to do the chemistry. They pay organic chemists to really purify things all the time. But I think that in the case of this Greenyard reaction, and probably many organometallic reactions, there's a real finesse that needs to happen. Okay, and so that finesse comes in when we're adding things to the reaction mixture. Okay, and so when we have the reaction mixture, let me draw my flask here. Okay, so when you have a reaction mixture, here's your reflux condenser. Okay, drying tubes on the top. Okay, here's a stopper, and here's your addition funnel. Okay, but when we do this, what we want to do is we want to get this to start boiling. Okay, once it starts boiling, that's a key that you are going to get this reaction figured out. Okay, it may take a little bit to get this to start boiling and bubbling, but it's well worth the pain and suffering, because once you get to this point, it's like, yes. Okay, it's a sense of accomplishment that can't be matched. So, but the way that you control how it's boiling, because you don't want a vigorous blowing up boil, and you don't want it to be really small boil. You want it to be kind of, oops, sorry. Huh. See, I was using my microphone here and I must have hit it. Okay, so and so what you want to do is control the addition of the butyl bromide, and that, as it's being added, is going to make this boil either more or less or consistently. And so that's the finesse of this, is that you want to add the butyl bromide at a rate that is going to keep this at a nice boil, not a minimal boil or an exploding boil, but a boil that is kind of nice and gentle. Okay, and that way you know that your reaction is going to do this. Now when that happens, this whole reaction mixture is going to turn like a dark color. Okay, I'm going to say black, but it's not really black. Maybe like brownish, grayish. I've seen it a couple of different colors. Okay, but regardless, you want to make sure that you are adding this and controlling it the whole time. Throughout the whole addition, you want to make sure that you're controlling it. You want to probably, in general, thermodynamics says we should speed up the addition of this to keep this at a constant thing, constant rate, constant boil. Okay, kinetics says that as well. So you probably want to increase slowly, but you're going to have to monitor that reaction for the whole time you're adding. Okay, and so and here's a guideline, 30 to 40 minutes. But the better guideline, I think, is to look at the reaction. Let the reaction tell you what it's doing. Okay, and so then anything is there, have it stir for 15 minutes, and then you're going to have a little bit of magnesium left. That's fine. Okay. Now another thing that's going on is people always have a question about the acetate ester. That is the same as helps if I could spell ethyl acetate. That's the same as ethyl acetate. Okay, and so again, we want to mix that with 20 milliliters of ether and then add that through the dropping funnel. Remember, it's not until you actually add the ether, the ethyl acetate, that this is not sensitive to water anymore. Okay, so here it's still sensitive to water. That's why we're adding it through the dropping funnel. Okay, and again, you want a nice gentle reflux. Okay, now, so again, you should add that, and it should take some time. The guideline here says 30 minutes, but again, you want it to be a nice gentle boil. You don't want it to be an exploding boil or a boil just barely. Now, in my experience with this reaction, I will also tell you, if it stops boiling, then the reaction is done. Okay, so if you're not monitoring that the whole time you're doing the reaction, if you're not monitoring it at all, what's going to end up happening is you're going to, if that reaction stops boiling, you're typically not going to have good luck or good yield. So you have to make sure that that reaction continues to boil through the whole addition of everything, so that you have the best yield possible. Okay, and so now, once you finish with all of that, now this is now we add water to get rid of the magnesium bromide, and now we are going to want to do a little bit of rapid refluxing, okay? And then we do the workup, okay? And so this here, the workup, okay, is a kind of a typical preparation or a typical workup with water, ether, sep funnel, okay? We use sodium hydroxide to keep it basic because the magnesium ions are going to want to form magnesium hydroxide, okay, and then come out, so that's going to help us do stuff like that, okay? And so there's nothing different here. One of the things that you can do is, again, here you can use the rotovap. That really helps with the yield here. Okay. Now, when it comes time to write this up, okay, IR, no NMR, but then we also want a let's see, what do we want? We want an index of refraction. Okay, the index of refraction, okay, is going to tell us really how pure the reaction was. Okay, so so we're not doing NMR. We'll do IR, index of refraction. You'll get a yield, and life will be good. Okay, so make sure you keep everything dry up until this page right here, okay? And then we're pretty good. We're feeling pretty good about this, okay? And so, okay, well, that is the pre-lab lecture for the Green Yard, and keep in mind that for however much I was let you be on experiment 11, experiment 12, I'm going to be really hovering over your shoulder to make sure everything is going perfectly smooth. So have a great day and enjoy lab.